All right, so last section, we talked about factoring quadratics. The reason we talked about factoring quadratics is so that we can today solve quadratics. So this is going to look a lot like, if you're asking yourself going, this looks a lot like what we did yesterday. It is. It's like yesterday was step 1 and today is step 2. So thankfully, if it looks familiar, good. So we are going to find where f of x equals 0, or the 0 of the function. And we're going to use the zero product property. Remember, product means multiply. 0 means that nice round number. That means nothing. 0. So if I multiply two numbers together and they give me 0, then either A can be 0 or B can be 0. So we are going to, you guys don't have to write this down. We're just going to use it. It's a pretty intuitive property that we use anyway. Okay, so if I wanted to solve the quadratic equation, x squared minus 5x plus 6 equals 0. The first thing I'm going to do is factor, like we did yesterday. So which two numbers multiply to give me positive 6 and add to give me negative 5? What do you think? Negative 2 and negative 3. We are going to use this zero product property for our next step. So this is what we did yesterday. Next step is new to us today. So we say this guy can equal 0 or this guy can equal 0. Either one will give me an outcome of 0. So I'm going to go ahead and solve each one of these. So my solutions are x is either equal to 2 or x is equal to 3. Both of these are solutions to the equation. All right, when we look at our next problem, I have x squared minus 7x equals negative 12. I need it to look like this first problem, where all my items equal 0. So I got to shimmy this Mr. 12 back with his buddies on the left-hand side. So I need this guy to look like x squared minus 7x plus 12 equals 0. Once I get it equal to 0, I can use the zero product property, and then life is good. So we want two numbers that multiply to give us positive 12 and add to give us negative 7. I know they both have to be negative. Yeah, negative 3 and negative 4. And we did a whole bunch of practice yesterday. If you haven't, if this process is still a struggle for you, the factoring process, I would encourage you to do more practice. There's tons of problems in the book. There's a whole boatload on the practice worksheet from yesterday. Practice is the best way to get, as I learned in college, a mathematical intuition. And when I heard that first, I thought, whoever was telling me this is crazy. Because I had a TA in college, and she said, and it was engineering. She said, what's your engineering intuition say? And I'm all, oh, it is not saying anything. 0, blank. But what happens is the more problems you see, there is a subconscious that clicks into place and leads you to a mathematical intuition. So, but the only way to get that is to practice it much. Yeah, Bryce.
Once I get to this point, can you just say that you're going to add 3 and add Did you sign paper?
I did.
You did?
I'll lose my credential if I don't show all my work. It's a math. No, I'm just kidding.
Oh.
Just joking. Okay. No, there is no oath. However, it is always good teaching to show all your work. Never skip steps. But that's a part of the intuition, knowing that my answer is going to be 3 and 4. I'm not going to skip my step. Here, I'm going to set both of them equal to 0. I'm going to solve them, so I get x equals 3.
Yes.
And x equals 4. So x equals 3 or x equals 4 are the solutions. The lesson is we move the 12 over so we get equals 0 instead of equals negative 12. All right. So let me show you how to use our graphing utilities to make tables and solve quadratics. I'm going to follow the same process. I'm going to get 0 on one side and everything else on the other. In doing that, I'm going to combine like terms. So in this case, I have to subtract 4 from both sides. And add x to both sides. So I want to know when 4x squared minus 13x plus 3 is equal to 0. And if you guys remember when we were factoring the ones with the numbers in the front, that is really kind of a long and arduous process. So if we can use a table to help us out with that, then that makes sense. So we put our function into our graphing utility. And I want to know when this guy is equal to 0. So I can look at the graph and see, but we're supposed to be using a table. So let's go ahead and make this a table. And I look and I'm like, this is kind of real positive, positive. Oh, so somewhere between 0 and 1, I'm going to have x, or my function equal to 0. So how about 0.5? Nope, it's not 0.5. It's not 0.25. Oh yeah, it's right there. So we want to keep going so we can find our other, it's right there at 3. So using a table, this is how we would use a table. Find our zeros. Just plug numbers, find where it's close, and then start splitting the difference and testing in between the two numbers. Let me pause. So here's the table that goes with this function. We're finding which x value gives us 0, and we find that x equals 1/4 or x equals 3 are the zeros. I've let the cat out of the bag and showed you how to find using graphing, but I will show you again. So you want to put y equals your function, everything that's not the 0. So x squared plus 2x minus 24. Y equals, let me, done. I would like it back. Go back, sorry.
Just keep going back.
Thanks. So y equals x squared. Oh my short-term memory is terrible. Plus 2x minus 24. And it does it for me. Where the y values are 0 is here at -6, 0, and 4, 0. So the answers are x equals -6 and x equals 4.
So they're not the opposite when you do it that way? It wouldn't be.
No, correct.
So you don't actually have to like do it in a table, it's just like.
That's just, yeah, that's an option. Boop. I don't ever use tables. But I'm teaching it because out of due diligence. Okay, so here are my graphs. We see that x equals -6 is a solution. Or x equals 4. I'm just finding the zeros. All right, so let's read this word problem together. Make sure you guys just write the correct information down. You don't have to write every single word. I would definitely write down y equals -0.03x squared plus 1.60x. So that function models the path of a kicked soccer ball. The height is y, the distance is x, and the units are meters. How far does the soccer ball travel? Okay, so I'm just going to do a quick sketch, just for fun. I know that we start, 0, 0 is where we start because the ball starts on the ground, 0 distance away from the kicker. And I know we are a frowny face parabola because it's got a negative. And I know eventually it's going to hit the ground again because we have gravity. All right, so here's a little sketch. We want to know how high does a soccer ball go. So we want to know what's the y value at the top. And then describe a reasonable, oh no, how far does a soccer ball travel? From here to here is how far it travels. And then from here to here is the height. And we want a reasonable domain. So what I'm going to do is I'm going to work smarter, not harder. I'm going to go ahead and graph this thing and get all these points from a graph. But remember, if you're using a graphing utility, you have to state, I'm using a graphing utility. You guys are going to do this on a portfolio this time around, but I just need to know what you're doing to get where you're going. Okay, so let's see if my short-term memory can serve me. -0.03x squared plus 1.6x. Ooh, how do you like my sketch? I nailed it. Okay, so at 0, 0, that's where we start. We land at 53.3 repeater, comma 0, and the maximum is at 26 2/3, comma 21 1/3. Let me take a little snapshot of this to put in our so big. Okay, so here's our real picture. So the maximum height, so let's answer these questions. How far does a soccer ball travel? So from here to here is, so it travels 53 1/3 meters. How high does a soccer ball goes? It gets to 21 1/3 meters high. And notice we used the y coordinate for that because the height is our y values. how far does the soccer ball travel? How high does the soccer ball go? Describe a reasonable domain and range for the function. So my domain is which x values are reasonable. It doesn't make sense to be any further or any less than 0 away from the ball. There's no such thing as negative distance. I can't walk backwards and go -4 meters. It's still 4 meters. So the domain starts at 0, and after the ball hits the ground at 53 1/3, he's done. I guess he could roll, but we're not going to consider that option today. And then the range, so that's my y values. So I guess I could burrow underground if we have one of the Avengers throwing the ball real hard, but then I'll pop our ball and it probably won't happen anyway. So it doesn't make sense to be any less high than 0 for this particular problem. And we don't get any higher than 21 1/3.